Hello students, today we are going to study about alkenes. Okay, so first coming to the preparation of alkenes. Okay, it can be prepared by alkynes. Okay, so alkynes having triple bond, naturally we can prepare the double bond, isn't it? So how can we prepare by these alkynes? We can take any alkyne. Okay, and yes, we will be reducing it with hydrogen. And how? Two methods we have taken. One, pelletized charcoal. Okay, what is this pelletized charcoal? Okay, here this is deactivated by sulfur or quinoline. Okay, and as a result we are seeing this pelletized charcoal is formed. Okay, and this is also known as Lindeler's catalyst. Okay, Lindeler's catalyst. Okay, and yes, second one we can take sodium. Okay, or liquid ammonia. So with the pelletized charcoal we are getting what? Alkenes. And which alkenes we are getting? We are getting cis form of alkenes. Okay, here you can see that yes, the arrangement of the alkyl group and the hydrogen, okay, in the same form. But when we take sodium or liquid ammonia, we get the trans form of alkenes, which is, you can see it is present in the opposite directions. Okay, so this is how these alkenes are prepared by the alkynes. And yes, don't forget what is Lindeler's catalyst. Okay, Lindeler's catalyst is what? Here this pelletized charcoal, okay, is used. In this it is partially deactivated by poison like sulfur or quinoline. Okay, so this pelletized charcoal is known as what? Lindeler's catalyst. Okay, now here if we are taking, this is a general example. Now specific example, if we are taking, this is acetylene. Okay, ethyne. From ethyne added hydrogen to it, pelletized charcoal. Okay, we get what? Ethene. Okay, if we are taking propine, okay, and taking hydrogen, adding hydrogen to it and pelletized charcoal we are using, we will be getting what? Propene, isn't it? Using ethyne you will get ethene. Using propine you will get propene. Okay, the number of carbon atoms which you are taking. Now coming to from how do we get it? From alkyl halides. These alkenes can be prepared by alkyl halides. Okay, here in this actually what happens, this one molecule of halogen is removed out. Okay, and as the result forming an alkyne. Okay, so here if the halogen is being removed out, okay, so it will be known as what? Dehalogenation reaction, isn't it? So here it is also known as dehalogenation reaction, and yes, it is also known as beta elimination reaction. How? See, listen. Here we have taken what? Ethyl chloride, okay, added what? Alcoholic potassium hydroxide to it. So now what happens? This chlorine is being removed, and yes, one hydrogen is removed from here, thereby forming the ethene. So here what is happening? One hydrogen from the beta, this is the alpha position, this is the beta position, isn't it? And so here from the beta position what is this hydrogen has been removed. So it is also known as beta elimination reaction, thereby forming what? The alkene. And yes, this chloride which has been removed, okay, forms potassium chloride as we have added what? Potassium hydroxide to it, and yes, water is given out. So this is how this alkene is prepared from what? Any alkyl halide. So now yes, alkenes can also be prepared by vicinal dihalides. So what are these vicinal dihalides? Okay, when the halogen is attached to the adjacent carbon atoms, okay, when this halogen is attached, okay, to the adjacent carbon atoms, they are known as vicinal dihalides. Okay, so this is also basically a dehalogenation reaction only. Okay, how it is a dehalogenation reaction? Because here we will be seeing this halogen will be removed. Okay, how? When we are taking this, okay, with this vicinal dihalide, okay, and reacting it with what? Zinc. Okay, so we are getting what? An alkene, that is propene. Okay, 3 carbon atoms, we are getting what? Propene. And ZnBr2 we are getting, because this Zn combines with this Br to form ZnBr2, and here thus this bromine is being removed. Okay, thereby this is a dehalogenation reaction, and yes, from this vicinal dehalides we have formed what? An alkene. Okay, the number of carbon atoms, how much there are, okay, that much it will be formed over there also, but yes, double bond comes due to the removal of this halogen from this compound. Okay, so now next, it can also be prepared from alcohols by acidic dehydration. So what is this acidic dehydration? Okay, here we will be using acid. Okay, and as a result we'll be seeing that yes, the alkene will be formed, with that water is also released out. So this is what acidic dehydration. We can see here we have taken what? Ethyl alcohol, and we have added what? Concentrated sulfuric acid heated at a temperature of 443 Kelvin. We are getting what? An alkene, and yes, water has been released out. So from ethyl alcohol we got what? Ethene. Okay, when we have reacted it with concentrated sulfuric acid, and when we have added this we got an alkene, and yes, the water has been removed, thereby knowing as what? Acidic dehydration reaction. Okay, now these alkenes, if we talk about, okay, we have seen right now that yes, ethene has got it is colorless and it has got faint sweet smell, but rest of the alkenes, they are odorless in nature. Okay, and they are insoluble in water. Okay, but yes, they are fairly soluble in non-polar solvents, okay, like benzene and all. Why? Because they don't have the polarity. If they have the polarity, yes, it will be soluble in water. Okay, but they are non-polar in nature. Okay, so they are soluble in the non-polar solvents. Okay, now when we talk about the boiling point, okay, so when the size goes on increasing, naturally the boiling point will also increase with the increase in size of the alkene. Okay, now if it is a straight chain alkene and it is a branch chain alkene, when the question comes over here, so if containing similar carbon atoms, and if it is in the linear form and when it is in the branched form, so what will be the boiling point? The boiling point of the linear one will be more than the boiling point of the branched one. Okay, the branched one will have the lesser boiling point than the linear form of that alkene, only consisting of similar carbon atoms. Now let us study about the chemical properties of alkene. Okay, I am taking a general compound of alkene. Okay, and general reactions I am showing, to make you understand, I am showing you general reactions. Okay, so here a general compound of alkene has been taken. Okay, and we have added alkaline KMNO4. Okay, in this, and this is known as what? Breyer's reagent. Okay, and temperature we have taken it in a cold condition only, 273 Kelvin. Okay, we will be seeing that what happens over here, this bond will break, and here what will happen, this OH will be attached, thereby forming what? Diols. Okay, it is forming what? Diol, and this is the cis diol. Okay, now next, when we are adding this hydrogen halide, okay, so in this also what will happen, as soon as we added hydrogen halide to it, this bond will break, and thereby here what will happen, hydrogen will attach to one carbon atom, and to the other carbon atom this halogen will be attached, thereby forming what? The alkyl halides. Okay, so now coming to the ozonolysis reaction. So what happens in this? We have taken the general compound, okay, writing it over here. Okay, added what? Ozone to it. What happens then? The bond gets clipped, okay, thereby forming the compound, the intermediate compound I will say, in which we see what? The oxygen has been added up. Okay, and then yes, secondly Zn plus H2O is added to it. So now what happens? It gets cleaved up, thereby forming what? Ketone. C, R, R, double bond O. Okay, two molecules are from, one from here, one from here. So two molecules of ketone will be formed. Okay, now suppose if we are taking another compound which is not symmetrical in nature. Okay, here we have seen that yes, there is symmetry, isn't it? So we have understood with the symmetrical alkene. Okay, here symmetry is there. Now taking an unsymmetrical alkene, okay. Suppose if we are taking CH3, CH3, okay, and here double bond CH2, okay, plus we are adding what? Ozone to it. This is what? 2-methyl propene, okay, 2-methyl propene, okay, added ozone to it. Now what will happen, beta? In this, as soon as we added ozone to it, what will happen? Here there will be a cleavage, okay, breaking of the bond will be there. So naturally forming what? CH3, CH3, okay, and yes, ozonolysis has been done. 3 atoms of oxygen getting attached, okay, and here CH2, and this is the product which will be formed on this ozonolysis when we add ozone to 2-methyl propene. Now we are adding what? Zn plus H2, okay. So now what will happen as soon as we added Zn plus H2O? Here this will have a cleavage, okay, and what will be formed? Here will be C, ketone will be formed, okay. This is what? Propanone, isn't it? And plus what will be formed? Here CH2O. So it will be forming what? HCHO. So this is ketone plus aldehyde will be formed, and yes, one oxygen is over here. It will be removed by, it will be getting added up with water to form what? H2O2. Okay, it is hydrogen peroxide. So with the unsymmetrical alkene, we are seeing, we are getting what? Ketone as well as aldehyde. And yes, when we have seen here with the symmetry of the alkene, we have seen in ozonolysis, we have got a ketone. Okay. Now, coming to this halogenation reaction, okay, of alkene. In this, any alkene, okay, it reacts with halogens in the presence of carbon tetrachloride or an ether, or ether we can say, okay. What happened here? The double bond breaks and halogen gets attached. Totally all single bonds present now, okay, and thereby as the halogen is being attached, okay, or being added to this alkene, it is known as what? Halogenation reaction, okay. Now, hydrogenation reaction. What happens in the hydrogenation reaction? To an alkene we add hydrogen, okay. And yes, here we are using the catalyst platinum, palladium or nickel, okay. They act as catalyst, okay. And here what happens, this hydrogen gets attached, this double bond breaks, hydrogen gets attached to this 2 carbon atoms, thereby forming a total unsaturated, saturated hydrocarbon having having only sigma bonds, okay. Now, when this alkene, okay, if we add water to it, okay, so what happens when we add water to it? And yes, few drops of acid also we add to it, H2SO4, okay. So we see what? This water is being added to this alkene, thereby what happens? We see it forms an alcohol, okay. So here we are seeing when water we are adding to this alkene, it what forms? It forms an alcohol, and naturally here the double bond breaks and alcohol group gets attached to the carbon atom. So we have studied about the reaction of alkene with the alkyl halides, okay. That halides can be chlorides also, iodide also, bromide also, okay. Now we are going to study addition reaction of hydrogen bromide with alkene, okay. So if it is a symmetrical alkene like ethene, okay, so when it reacts with HBr, what happens over here? Okay, CH2 double bond CH2, okay, and plus H plus Br minus, okay. So what happens over here? Movement of the electrons over here, isn't it? And naturally what happens here? CH2, okay, this becomes what? Positively charged, and this CH2 becomes negatively charged. Okay, now what happens over here? We are having H plus and Br. Okay, so this H will be attached with this and Br with this, thus forming what? Ethyl bromide and making it a stable compound. Okay, now when we are taking an unsymmetrical alkene, okay, so here two rules work. That is the Markovnikov rule and the anti-Markovnikov rule. Okay, so when we talk about the Markovnikov rule, okay, here all can be there. Okay, chloride, bromide, iodide. Okay, so here what happens for unsymmetrical alkene we are taking, this is what? Propane. Okay, propane reacts with what? Hydrogen bromide, and yes, two products are formed, one major and one minor. Now let us see how it works. Okay, so this propane, okay, as soon as we add HBr to it, what happens? It forms two compounds. Okay, here you can see that CH3, CH2, CH2, here a carbocation has been formed. Okay, plus Br minus. Okay, here in this we are seeing CH3, CH, CH3 and Br minus. So here two alkyl groups are there basically. Okay, so now what happens? This we are saying less stable and this one we are saying more stable. Why? The two carbocations are formed. First one we are saying less stable, second one we are saying more stable. Actually, why we are saying that? Here what happens in this, we will be seeing that yes, all the electrons are moving towards this carbon atom. Okay, and here we are seeing what? In this, here also the electrons are moving from this alkyl group also and this alkyl group also to this carbon atom. Okay, so what happens? It receives this electrons from the two opposite sides, thereby making this carbon atom more stable in nature. So what happens over here actually in this case? Okay, here we are seeing it is moving in one direction only. This I effect we are seeing in only one direction. Thereby here we can see that as we go more towards the left, okay, what happens? The movement of electrons, okay, it goes on being less in nature. Thereby this carbocation remains as a carbocation only. Stability is not so much. As a result, it will try to shuffle and form this product only, this compound only, propane. Okay, but yes, some reacts with this bromine, okay, and as the result we get the minor product. Okay, and here as this carbocation is more stable, we get the major product over here. Here we have got water, 1, 2 and 3. It is what? 2 bromopropane. Okay, and here we have got water, 1 bromopropane. Okay, so the major product is what? The 2 bromopropane. Okay, and the minor one is bromopropane. Okay, now anti-Markovnikov's rule. What happens over here? This happens only with HBr, hydrogen bromide. Okay, it is anti-Markovnikov's rule. We are saying it is also known as Cross effect. Okay, and here we will be adding what? Peroxide. Okay, here we can't react with HCl or hydrogen iodide. Now let us come to the anti-Markovnikov's addition reaction of alkene. Okay, so in this again we have taken an unsymmetrical alkene, that is the propene, okay, and added HBr in it. Okay, so here mind it that we will be using only HBr, not HCl and not HI. Okay, and yes, in this anti-Markovnikov's addition reaction of alkene we use what? Benzol peroxide. Okay, and in this we will be seeing that yes, in case of the Markovnikov's rule, we have seen that this product was the minor product. Okay, but here in this case, this will be the major product. It means it will be formed more. It means bromopropane will be the major product, not 2-bromopropane. Okay, now let us see how this reaction has came, its mechanism. Okay, so as we have taken here benzol peroxide, okay, what happens in this? Homolysis takes place. It means it breaks. Okay, and yes, two identical, okay, compounds will be formed. In this we are seeing that this oxygen over here is not stable. Okay, as soon as we heat it, what happens? This oxygen, it will try to be stable. How? Actually, the electron is taken, which is being shared, is taken by this carbon and this benzene, and naturally now this oxygen, it reacts to form a stable product, that is the carbon dioxide. And yes, as it has taken the electron, here free radical of benzene will be formed. Two molecules, because here two has been formed. Okay, so we have got a free radical of benzene. Okay, two molecules of free radical of benzene. Okay, we are taking only one. Okay, reacting with HBr. Here what happens? Free radicals of H and Br are formed. Okay, and as a result, this H combines with this free radical of benzene to form total stable compound, that is benzene. Okay, and yes, we get a free radical of this bromine. Okay, so now this bromine free radical reacts with this propene. Okay, so here also what happens? Free radicals will be formed again. Okay, so naturally in this what will happen? Here CH3 CH2, okay, a free radical of CH2 formed. Okay, and here this bromine comes and attaches to this carbon atom. Okay, now here HBr is also present over there. Naturally here also free radicals formed of H and Br. Okay, and this H, this combines with this one free radical of CH2, forming thereby a stable one CH3. Okay, and plus this Br free radical comes over here. This is the minor product. Okay, then now the next one, okay, which we have got, that is CH3, okay, and here CH free radical has been formed, because here what happens, this free radical of bromine attaches to CH2. Now, and yes, HBr is present over there, so yes, this also breaks into two free radicals, H and Br, okay, and this H, it joins with this H over here to form what? CH2, okay. And yes, Br has been joined over here, so naturally here it is forming bromopropane, and yes, one Br radical is given out. Okay, so why this bromopropane is more stable, okay, and forming the major product, and why this is less stable and forming the minor product? Actually what happens over here? Here it is receiving the electrons from this, okay, this is giving the electrons, okay, and thereby making it more stable in nature. But here what happens, this is giving the electrons, okay, it is coming here, but it is showing its effects towards the bromine, okay, not to this, and as the result making it less stable and this becoming more stable in nature. Now let us study about the polymerization reaction of alkenes, okay. So here we have taken one alkene, that is what? Ethene, okay, okay, N number, it means undefined, okay, number of ethene molecules, okay. We have given what? High temperature, pressure has also been applied, and yes, catalyst also will be taking, okay. We will be getting what? Polyethene, okay. So this is what? A long chain of ethene molecules, okay. They are polymerizing, forming a big chain, forming a big polymer rather, okay. That is the polyethene, okay. Now we have taken what here? Propene, okay. So here number of molecules of propene, okay, temperature given, pressure given, okay, catalyst added, we will be getting what? Polypropene, okay. So here the difference you can only see that here branching also starts, okay, and this is also a big chain, okay, thereby forming a polymer, and that is polypropene. Okay, so this is how polymerization takes place in case of the alkenes. So we have studied all about the alkenes preparation, physical properties, chemical properties, okay, and hope you might have understood it. Good day, take care.